Hello everyone. Let us now discuss how can we solve this problem lexicographically smallest string after applying operations. So let us look at the description first. So we are going with string s of even length. That means it is like 2, 4, 6, something like that, consisting of digits from 0 to 9 and two integers a and b. So we are given with the string s and two integers a and b. You can apply either of the following two operations any number of times and in any order on s. So we can apply these two operations. Let us see what are those operations. Add a to all odd indices of s. That means 1, 3, 5, 7. These are the odd indices and we can add a to that all indices. Digits post 9 are cycled back to 0. Let me tell you that if I add 4 to 8, then I'll get 2, right? So 8 plus 4 is 12. If I do a mod operation with 10, I'll just get 2. No need to worry about that. S is equal to 3, 4, 5, 6 and A is equal to 5. S becomes 3, 9, 5, 1. I think you understood. Rotate S to the right. The second operation is rotate S to the right by B positions. For example, S is equal to 3, 4, 5, 6 and B is equal to 1. S becomes 6, 3, 4, 5. What if B is equal to 2? S becomes 5, 6, 3, 4. Right? First 3 will go and then 4 will go. Now return the lexicographically smallest string you can obtain by applying the above operation any number of times on S. A string S is lexicographically smaller than string B. You know the meaning of lexicographically. I don't waste our time by explaining that again. 5525 is the given string, right? Let us take the given string 5525. 5525 is the given string. What are A and B values? A is equal to 9 and B is equal to 2. Let us do one thing. Let us go with what is given in the example and let us see why 2050 will be the lexicographically smallest one. Now, uh, 2 triple, let us see like this. First, we are asked to RAA, rotate, 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 add. So I'll write that rotate, add, rotate, add, rotate, add. I'll go by this and I'll stop at 2050. I'll tell you why I am stopping there itself. Rotate. So that means operation 2. I'll do operation 2. Then B is equal to 2, right? So if I move two places to the right, so I'll get this. Now add. So 9 plus 5 is 4 here. 9 plus 5 is 4. 2, 4, 5, 4. Now add again. 9 plus 4 is 3. 2, 3, 5, 3. Odd indices 1 and then 3. Now rotate. So 5, 3, 2, 3. Now add. 9 plus 3 is 2. 5, 2, 2, 2. Now again add. 9 plus 2 is 1. 5, 1, 2, 1. Now rotate. 2, 1, 5, 1. Now add. 9 plus 1 is 0, 10, right? Again 0. Okay. Now let us do two things here. Rotate. First add, right? If I add 9 to 2050, I'll get 2959. If I rotate 5020. So if you see, these two strings are greater than the string which I got here. And let me tell you that these two strings will be present before. And there will not be more than 10 permutations and we will land in the same loop. So we had got this 2959 somewhere in between. I'm saying that I need to stop here itself. How can I know that? I'm saying that I got this already previously, right? So I need to use a visited set which stores the visited or already already seen strings, right? So that I don't go in the same loop. This is the first thing I need to do. And minimum string is the string I need to return. So minimum string is our string which is given to us. Now I'll write a recursion something like that with the given string s and integers a and b. I'll do operation 1 on string s with a, operation 2 on string s with b, and if already seen s is already seen, then return here itself. And the minimum string is equal to minimum of minimum string comma s. So this is how we solve this, and in the main code we will return the minimum string. This here I'm going with the depth first search. We can go in the breadth first search also, but I'll give you the both codes. But let us see what is operation 1 can do with S and A. So in operation 1 we are asked to go with the odd integers for iterate, and if odd index add A, and at the last return string. Okay, now create a temporary string with operation 2, right? We will be returning string. So in return of string here, now in operation 2 with b, temporary is equal to s dot get the substring starting with 0 and b size, and add s dot erase b number of positions first, 0 to b, and then s plus is equal to temp. Let me tell you how it works. I return s at the end. I'll tell you how. S is 5525 and B is equal to 2. So first what I'm saying, temp is equal to S dot substring 0 and B positions nothing but B size is nothing but 2. So temp will be 55. What I said again, S dot erase 0 comma B. So these two will be removed. And what I said, S plus is equal to temp. So 25 is the string plus 55 is temp. So 2555. So this will be written, right? So this is how we solve this, and I have given the code link in the description. It contains both the DFS and BFS approaches, so you can go and check it. Thanks for watching this video. Please do like, share and subscribe to my channel. Thank you.